Everyone, welcome to this session on the Human Immunome project. There is a joke about the immune system. In this joke, a terrorist captures two physicians, a cardiologist and an immunologist, and tells them that he will spare the life of whichever one did the most to save humanity. The cardiologist starts speaking about all his wonderful discoveries and the breakthrough therapeutics that he has pioneered. And the immunologist starts by saying, you have to know that the immune system is complicated, let me first explain. And the cardiologist says, oh, just shoot me now. This is what is at issue today. Our immune system is thoroughly complicated, and it is one of the senses through which we feel the world, except we are completely unaware of it. Even seemingly very simple questions, very practical ones as well, such as, how badly is the next wave of COVID going to hit us now that we have immunity? How well are we protected? Seem to be much more out of reach of our understanding than we would like them to be. Today with us, we have a number of people who are going to speak to the next step in research on immunity. We will start with you, Wayne Koff. You are the President and Chief Executive Officer, first of the Human Vaccine Project, which has now been renamed the Human Immunome Project, with a very ambitious project to put together AI and our knowledge of immunity to bring us perhaps several steps forward. Could you tell us a little more about what the project is, what you see as the main promises, and perhaps also pitfalls?
Absolutely. Do you want me to go up here, or should I sit here?
As you wish.
Okay. So I've got another joke for you, and that is we've all been in this situation. Each year we see our doctor and we walk in, and they give us all these tests, and they tell us our creatinine levels, our bilirubin levels, and then we ask the doctor, "How's the immune system doing?" And he looks at me like I'm an alien because he doesn't have a clue. And that's really where we are. Each person, each individual has an immune system that is unique. It is unique because of the age of the individual, his genes, the microbiome, what they've been exposed to, et cetera, et cetera. And COVID is a perfect example of this. The virus infects hundreds of millions of people, and we see the asymptomatic curve. Individuals on this side are asymptomatic, in the middle have the mild disease, and on the right side have severe disease and death. We don't know why. It's the same thing if you receive a vaccine. Individuals on this side over here, if they get one immunization, are protected. Other individuals have to have 3 or 4, and other individuals are not protected at all. We don't know why. And we haven't been able to understand the immune system, as Samir had said, because it is billions of times larger than our genome. And it consists of molecules and organs and cells and tissues, et cetera, et cetera. So we've never had the tools. Recently, in the last decade or so, we now have the tools, the incredible assay tools in the immunology space to look at individual cells and molecules and lymphokines and cytokines, etc. Our challenge, though, is we have an unprecedented amount of data, and we don't understand the data. Luckily, though, in the past decade, there have been incredible advances in AI and machine learning, et cetera. And so what we want to do in the Immunome project is to bring these two of the worlds into one. So we held a meeting just at the end of last month in La Jolla, where we did exactly that. It was the Human Immunome AI Summit. It's the initial one of a range of meetings we're going to do all over the world. We'll do one in Africa, we'll do one in Asia, we'll do one here in Europe, and such. And the goal of the meeting, which brought together leading immunologists and systems biologists and AI experts, is to begin to understand how do we get from where we are now, which is a lack of understanding of the human immune system, to where we want to get to, which is the AI model of the human immune system. And the impact, if we are successful, is going to be across all diseases. Infectious diseases, the ones we haven't been able to tackle, like AIDS, TB, malaria, the NCDs like Alzheimer's and cancer and MS, et cetera. And we need a lot of help. We need to have a series of partnerships from academia and industry, NGOs, and governments. We need to have labs all over the world on this problem. We need to work in Africa. We need to work in Asia. And we need to work in the individuals who are most vulnerable on a range of diseases, which are the elderly, the maternal infants, and those living in the developing world. So that's where we want to get to, and I'll stop there and we'll move on.
Thank you. We have two participants online, Jürgen Schmidhuber and Jacques Ferret. Jürgen Schmidhuber, you are the AI scientist here, and as we could read in your bio, since age 15 or so, your main goal has been to build a self-improving artificial intelligence smarter than yourself and then retire. It seems that in order for the Immunome project to work, you would have had to have succeeded, and yet here you are. So what can you tell us about this project, why you find it exciting, and what you see as its main challenges?
To improve the state of the art in immunology and in other fields of biology, you don't have to build something that is smarter than human. It's okay to have something like an artificial biologist or an artificial chemist, which learns about, for example, chemical reactions. How does that work? So in modern AI, we have these deep artificial neural networks, and they are a little bit inspired by the human brain. In your brain, you've got about 100 billion little processors called neurons, and some of them are input neurons where video is coming in and audio is coming in form of numbers, basically. And then some of these are output neurons, and whenever they are switched on, they trigger your finger muscles or your speech muscles and so on. And then in between, there are lots of hidden neurons, if you will, and all of them are connected by about 10,000 connections on average per neuron, which means you have 1 billion connections in your brain. And in the beginning, when you are a baby, all of these connections are apparently pretty random. But then over time, some of them get stronger and some of them get weaker. The influence of one neuron on another changes over time through learning. And the same is true for our artificial neural networks that are big and deep and learn to predict, for example, what's going to happen if I do that and apply to chemical reactions. For example, you have all kinds of ingredients as you are trying to predict what's going to come out if I'm putting these substances together under these pressures and under these temperatures and with those catalysts, and something will come out at the end. And in chemistry, much is known, but many things are not predictable yet, but we can train on millions of reactions, these artificial neural networks, to become really good predictors of what's going to happen as a consequence of the inputs. And then we can take this deep model, this artificial chemist, if you will, and we can work it backwards, and we can say, okay, how do we have to change the input conditions such that a desired output substance comes out which has certain properties which I have never seen before. For example, maybe I can develop a ligand which is able to dock onto a certain part of the COVID virus in a way that inhibits its self-replication machinery. And the jaws of molecular biologists and chemists, they really dropped when they saw that this approach can enormously reduce the search space. It's not perfect, but many predictions of these artificial neural networks are also true for substances that they have never seen, and they can make very good suggestions for how to improve the input conditions such that the desired outputs come out. And this is a very general approach which applies to biology, to chemistry, to material science, to the production of solar cells, for example. All kinds of material science are affected by that and are being currently revolutionized by this approach. And the benefits for healthcare and immunology in particular are obvious, and all of that is super promising.
And more specifically, on the Human Immunome project, what would you say we should be hoping to come out of this project from your point of view?
Yeah, and so you want to better understand how do cells work, and how do what kind of drugs can help to boost the immune system in a way that is good for the owner of that immune system. And then again, there are in immunology, there are hundreds of classes of prediction tasks where you want to predict what's going to happen if I do that or that. How is this cell going to react? How is this protein going to fold in a way that allows it to dock onto some other critical place in the immune system? And to the amount, so it depends on how much data you can collect from many different people to the quality of the systems that are going to predict the consequences of actions depend on the data that you can collect from people. And here there is one big issue, which is privacy. So in certain authoritarian states, privacy is not an issue, but in Switzerland or in most European or Western nations, it's a big issue. And what often happens is that you have the same patient and he goes to 3 different departments in his hospital, and each of them is extracting some sort of data from this patient. And these 3 different departments in many hospitals don't share their data for a whole bunch of reasons. So what you really want to have is a system which collects lots of data from lots of different persons in a way that keeps their privacy sphere intact. And this is leading to all kinds of challenges, but there are also solutions.
Thank you very much. We have spoken about partnerships, also about promises and pitfalls. Chorchwantan, you represent in a way government here. You're the Chief Health Scientist of Singapore's Ministry of Health. Thank you so much for joining us. What is the role of government in your view, and how would you react to what you've heard so far?
Yeah, thanks very much. I would say during the COVID pandemic, all of us, particularly myself, had a crash course in immunology and talk about a redefinition of on-the-job training. some of the things that we learned through COVID are very relevant here. As I think has been highlighted, there is a lot of data already available and a great deal of insights that can be discovered if you're able to link the data up and to interpret patterns and to understand what is going on. But I think the key issues, as Jürgen was explaining, is firstly how to make the data interoperable. Because the data are collected in different ways, different formats, so how to make it interoperable. Then, after that, what is the permissibility to share this data and do analysis across data sets? And the permissibility in the case of patients who volunteer for research is through consent, but a lot of the data is also collected from health systems as part of looking after patients. And so to establish the permissibility to use that data to share it is very critical. And finally, of course, what are the safeguards you need to put in place that would allow very innovative research to carry on, but yet preserve public trust? Because at the end of the day, we have to do this over a long period of time, and so the preservation of public trust is very critical, and therefore the public, we owe a duty to keep the public informed as to the safeguards we put in place to make sure that even as we extract insights from their data, we are taking all the steps necessary to protect their confidentiality. So I think government can play a very important role here by looking at these various issues. How can we establish the conditions by which data are collected in a more interoperable manner across data sets and across settings? What can we do to establish the permissibility to use that data, particularly data collected by health systems? And in Singapore, we have taken some steps towards that and have done some proof of concept types of work to demonstrate that can be done and is acceptable. And then you need a technical and a governance infrastructure by which people, users can apply to use the data, and the safeguards can be put in place to ensure that authorized users with an objective that meets the goals of protecting confidentiality are met, that those individuals are able to access those data. So I would say that governments play a critical role, in a sense, in setting the policies, the rules, the protections that then provide sufficient public assurance to allow data exchange to occur. Final thing I would say is this is already very, very difficult within a country. And when you think about sharing data across jurisdictions, the challenges are compounded, and therefore we do need additional approaches like federated learning approaches that allow interrogation of data in situ without having to move data across jurisdictions. But it's a very ambitious and a very exciting project, but we do need to address the fundamental issues of data in order for it really to proceed at the scale that's required.
Yeah, that's an important challenge. In our own research here, we looked at what were the components of trust for people to share their data. And of course, trust has many parts, and one of them is knowing who you're supposed to trust. So as the further you go, the harder this becomes, and this is just one of the challenges here. But this is a perfect transition, because Soumya Swaminathan, you represent the World Health Organization here as chief scientist, and part of your role is to ensure that norms, standards, and guidelines produced by WHO are scientifically excellent, relevant, and timely. What sorts of guidelines do you see as scientifically excellent, relevant, and timely in this new area, and what are your views here?
Thank you. And I really agree with everything that Dr. Tan was saying, and this is also an area where WHO is trying to play a role, because we saw during COVID the importance of timely data sharing in being able to drive policies that impact people's health. You know, whether it was data from clinical trials that were still unpublished, and the usual practice, of course, is you publish your data first, you get your authorship, and then you think about sharing the data. But we used a different model, which is prospective meta-analyses, where all the principal investigators were contacted in advance. They agreed to come together and share their data with the WHO's guideline development group that was updating their systematic reviews. And then at the same time as the guideline came out, the papers were also published, so they got the publication. So moving into more a living approach to guidelines is what definitely we are going towards. This also involves having digital platforms, because the old ways of doing things where you are printing hundreds of pages or putting out PDFs is no longer the way to go. We should have so setting the standards and the interoperable data standards is also an important role for us, and as part of our global strategy on digital health, we're doing that to enable countries to put in place exactly the governance, stewardship elements, the financing elements, the infrastructure, but very critical is the data sharing policies. So we just recently had a series of discussions around sharing of genomic sequence data. And genomics, of course, now everybody knows about variants and about sequencers and things like that. Even ordinary people understand what it is. But there aren't, again, globally accepted norms on how to share, how to give credit to people who are sharing, because I think that becomes an important issue when we're talking about global collaborations. That what researchers from the Global South tell us is that when they share data quickly in open public access platforms, then either the papers are written by people in other parts of the world and they're sort of scooped, because once you make your data available, then anyone can use it. And sometimes they're not even credited with generating that data. So I think that's an important ethical consideration for us as we think about this Immunome project. And the other thing, of course, we saw during COVID is that open data sharing sometimes resulted in punitive measures, like the travel and trade bans imposed on Southern Africa as soon as they found the Omicron variant and made the data available, which was to help the rest of the world prepare, but instead they were punished. And so again, this raises very serious issues for how we conduct science globally, and if there are going to be such disincentives for people to share data, then that's not going to happen. So in terms of, just as an example, the WHO Science Council, which is chaired by Professor Harold Varmus, they decided genomics would be their first big project, and they released their report a couple of months ago, which was about accelerating access to genomic technologies around the world in an equitable way. And they have several recommendations there which we need to follow, but the idea was that countries need to invest in genomic technologies because of the broad impact it can have for health, not just for pathogen surveillance, but for prevention, for prediction, for diagnostics, as well as for treatment, like the new gene editing technologies and so on. And all of these have to be accompanied by, I think, ethical frameworks as well. So that we also produced, in fact, just before the Genomics Council report last year, a framework on addressing the ethical and regulatory issues around gene editing, because this is a technology rapidly advancing. But in parallel, we had a separate group working on the ethics and regulation required around artificial intelligence. And here, of course, we're talking about AI applications for health, direct, like using AI for a diagnostic test, or using AI to make prognostic or to drive treatment, not in the upstream research that we're talking about here, but when it has direct implications for people, then we need to have a framework on how that AI is used. So I think that the document is extremely useful because it speaks not only to ministries of health on how to govern something like this, but also to developers of AI. It has principles on what you need to be aware of, the representativeness of the data, the transparency of the algorithms, and so on. That's the way to build trust as well, because if everything is in a black box, and then you tell people to blindly believe the outcome, then it raises all sorts of issues. And we can talk about communication, science communication, and misinformation, and so on later. But I think those, especially when we're addressing complex issues, and around vaccines, we saw the kind of debates that are still going on. and the questions that people have, and some of them are very genuine questions, and others, of course, are driven by sort of the disinformation campaigns. But I think we have to do a better job of explaining science to people, what we know, what we don't know, and how science advances, really.
And one of the issues that we might get back to later on is also about distribution of risks and benefits, because this, of course, is one of the challenges that we have collectively in the world visibly failed to rise up to on many occasions, and how to do better. But I would like to give the floor. Oh, so yes, you would like to do a follow-up. Please go ahead, Jürgen.
I thought it's very interesting what we just heard about regulation and about data collection. And I think there is a simple answer to it, which is just waiting to be implemented. We should have a market-based system for data. If it is true that data is the new oil, then it should have a price, just like oil. And the oil price is determined on the spot market, and it changes all the time. And who should own the data of all these patients? Well, obviously, the patients should own the data and should decide what to do with it. And who are the players in the system? There are the generators of the data, who are the patients who are sick, and then there are the extractors of the data, the hospitals, which have fancy machines to extract the data from patients, and then there are the guys who are interested in the data, like companies like Siemens or GE or Google, and they would like to take the data and train their deep artificial neural networks to predict, is this guy going to have diabetes soon? Given this history of this patient, is this guy going to have a heart attack soon? If we have this therapy, what is the most likely extension of his lifespan, and so on? So from the data, you can learn questions like that. But as has been pointed out, the data often is not available because there are all kinds of ethical concerns and regulations, and different governments, as was pointed out, have different approaches to this topic. Now, if we had a data market, all these problems would go away because every patient by himself would decide for which price am I going to sell my data. For example, a guy who has a very standard form of cancer, he will not have as valuable data as somebody with a very rare form of cancer. And the price will reflect it. There should be some exchange, some data exchange, where you really get money for the data that you own as a patient. So every patient should be able to become a micro-entrepreneur in his data. And for example, on a little app on the smartphone, you will then see, okay, Siemens is offering $10,500 for a patient who has these conditions and these particular histories of other diseases, and is taking these particular drugs and has diabetes too. And then the price will go up and down. Maybe somebody else, IBM, is maybe going to offer 12,200 or whatever. And each patient by himself can decide whether he is willing to sell his data for a certain price or not. And it would be not so difficult to implement something like that. It just should be, it's a matter of regulation. The first country that has a working system like that could be Singapore or Switzerland or some other small country. As soon as it works well, it will be super attractive to all these surrounding countries, because the people there will learn, oh, I'm sick, but at least I can make some money with that. And it's a super exportable scheme. I think once it's starting, it's going to conquer the entire world rather rapidly, just for market economy-based reasons.
Yeah, of course, I haven't forgotten.
Yeah.
This is a brilliant topic for the general discussion, but we have yet one more speaker to hear. So I would like to first, so hold that thought, we'll come back to it, I promise. But first, Jacques Fellet, you are the quote-unquote outsider here, but the one also with experience in a close area. You're the founding director of the Precision Medicine Unit at the Lausanne University Hospital, and you lead a genomics laboratory at the EPFL School of Life Sciences. Could you share a little of your experience with us and tell us what advice you would have and what role you think government should play based on your experience in this nearby field?
Yeah, so I can tell you about what happened in genomics, because we basically were in the same situation 25 years ago in the genomic world, and part of the community at the time did not believe that it would be possible to get worldwide efforts that would lead to first a human genome project and then the 1,000 genomes project and others. And still it succeeded. So it was possible with retrospectively easy targets, because reading the genome once and for all, it was a well-defined objective that wasn't that complicated, and we could call it a day at the end of the 3.2 billion letters of the genome. So much easier challenge retrospectively, but that looked infeasible when we first started in the 90s. So we are pretty much at the same place with the Immunome project today. It's not that we have a blank page and nothing has been done. There are excellent research groups working on putting together the knowledge on immunity since decades, and especially over the past few years, thanks to advances, especially in AI. So we have solid basis to start working on, but it is true, and it has been alluded to already, that some of the main challenges are related to accumulation of enough data and transnational sharing of those data in a way that respects individuals. And here, there is something that is slowly happening, and that should be accelerated, and the Immunome project can be some kind of a catalysator for that. It's the transformation of the healthcare system into research enterprises. And this will be needed for this project, will be needed for all healthcare to become much more reactive and much more of a learning experience for everyone. And if we want to accelerate the improvement of tools and drugs and strategies, we really need every citizen, every patient that is willing to share the data and to become a research participant to get this option of opting into being a research participant. And with that, I think it will be possible to little by little decipher the different layers of immunity. And maybe I'll just add one thing here, because we are at GESDA and we also need to convince people that are not familiar with immunity, even after COVID, why Immunome and why don't we do a Manhattan project on cardiology or dementia or whatever. It is because immunity is not only vaccine and drugs for infectious disease or autoimmunity. It's really at the heart of most, if not all, of the common diseases that will impact us all and will impact our societies. So immune dysregulation, chronic inflammation, they are really causing cardiovascular disease, kidney insufficiency, liver cirrhosis, dementia. So they are at the center of most of the health problem of the 21st century.
Thank you very much. As we saw, many of the problems and challenges that you touched upon, but also some of the promises, can cluster around the issue of fairness, around the issue of how are the distributions done for risks and for benefits. Jürgen, you proposed an option for a solution. Let everyone decide for themselves how much money they're willing to take to part with their data, or perhaps not entirely part with it, because they would still have it, right? So it might be more use of data rather than the data itself that gets bought and sold, which makes it a weird market, right? Because you could sell the use to many different people, but you might have exclusive use. So there are lots of details to be ironed out, as you're no doubt aware. But these issues of distribution, I would like to go another round if you are willing to touch upon them. What do you think are the main problems there? The idea really is, if this is to be kept on the right track, what does the right track look like? What should be the future of this? Since we're also talking about the sorts of regulations that might be needed, we have to have a vision of the way ahead and which way we want to go, right? These are areas where sometimes one person's dream is another person's nightmare. So how do we sort these things out? What is the dream here? Who would like to go?
I just have a quick point to make, and that is perhaps we should start with thinking about equity issues right from the beginning. Mm-hmm. Because very often we think about it at the end when we're already seeing that there's some large numbers of people who are left out. Mm-hmm. And so even when we're thinking about new technologies as well, we have to start thinking about equity. In AI, of course, this is very important because of the representativeness of the population and the data that you're feeding into the algorithms. But I think thinking about equities and building those private-public partnerships because the private sector has a very important role to play, and they need to work with, with the public sector. But the public sector really needs to take responsibility for driving it.
I would agree with that. I think that in the range of discussions that we had, industry has to play a really, really important role. Industry has a huge amount of data, and all the researchers in industry are really excited about the project. The lawyers, though, in each company are really an obstacle, frankly. It took us at least 1.5 years to get a lot of data out of one of the companies. There are hundreds of companies out there. So I think the role of the WHO in a coordinating fashion is going to be really, really important in something like this. Equity also, and the major point that had come up in the meeting that we had a couple of weeks ago when we had launched the project, was that you have to begin with impact and you have to begin with equity. And in a past life, as you know, I worked on HIV vaccines all over the world. And you have to be on the ground in Africa. You have to be on the ground in India. You have to be on the ground in regions of the developing world, where the impact eventually of this is going to be the greatest.
Yeah, for many of us, the starting point really is the main beneficiary should be the public society at large. And when we do surveys asking the public in Singapore, and it's true in other countries like UK, they are quite happy to share the data and materials if it's run by either governments, public research, for public good. They tend to be less enthusiastic if it is for-profit reasons. And there are also other embedded concerns, like will insurance companies get hold of these data, and who's going to prevent bad things from happening to me, which we have to address along the way. So I would kind of think that the starting point is for us to think that the main beneficiary would have to be the public at large, that they have to perceive that this is good, that there are some risks, but they're being mitigated, but generally it's going to be good for patients, for health, for societies. And if we do that, then it does mean that we have to establish policies and regimes that would help to build further on that trust, and then inoculate against the breaches that may occur. Some unintended bad things might happen, but generally I think people have to really believe that this is going to be really important and good in the longer term. And so I feel that that, for us at least in Singapore, is the principal driver of how we frame and think of the policies that need to be put in place, the public communication that has to go out, the demonstration of positive impact to show how powerful these data can be applied and create really positive benefits for individuals. I think it's not so important for each individual to experience the benefit, but the fact that other people in the community are benefiting is generally sufficient. And therefore, I think this is something that, at least from where we sit, that's what we are attempting to strengthen and to build for the longer term.
Thank you. Jacques, would you like to pitch in? Jacques Follet, would you like to pitch in?
No, I have nothing to add. I fully agree on all counts on what was just said.
And Jürgen, would you like to pitch in now?
Yes. So I think what we heard from these brilliant panel participants really can all be addressed through market-based systems where equity is addressed, where the general good is addressed, where the market is going to find out through sell and buy operations what is the true value of the data. At the moment, we don't know the true value of the data, but the market is going to find it out, and everybody can participate in that market as a micro-entrepreneur. So many of these problems that governments currently see, they are going to go away. Just 10 years ago, in 2012, my team was the first in the world to use deep artificial neural networks to win a competition in medical imaging. That was about breast cancer detection. So we had slices through the female breast as data, and then you see these little spots there. Some of them are harmless, and others are cells in pre-cancer stage. They are called mitosis. And before we did that, other techniques were used by hospitals to, mostly humans were used by hospitals to detect these dangerous signs. And then we just had a very stupid artificial neural network which learned from the data to become as good as a human histologist, also generalizing on data, on pictures that it had never seen before. But back then, we had just a tiny amount of data, although everybody is using the same approach today in all kinds of healthcare, it's still this one big overshadowing problem, which is the lack of data, because all kinds of different regulations are coming in, ethical concerns and so on, because there is no Western response to the way of the authoritarian nations who just own the data of all their people, so to speak. But the Western response is really have a market-based system, which even gives an incentive to the healthy guys, because you need the healthy guys also to see the difference in the data between the sick guys and the healthy guys. So such an incentive is not present, for example, in countries like China, but in a market-based system, it would be fully present, because the market would figure out a price for the data of the healthy guys, depending on how important it is. So I think many of these regulation issues would really go away through a market-based system.
I have to pitch in here that it has not escaped the notice of many people that markets tend to do better at reaching fairness on paper than in real life. And so there is still, I think, a question of what sorts of regulation and conditions would ensure fairness, but beyond that, ensure trust. Because it's not enough, even if it did work, which, I mean, show me the data. Even if it did work, there is still the issue of would people trust it enough to actually participate, and this is linked to people's representations rather than to what markets actually do. So I think this is a very valid point, but it does need to be worked out a little more. Yeah, I don't know if anyone wants to react.
Well, I think the other issue is the capacity building that has to be done. If we're going to work on the ground, each of the major immunology labs all over the world can do the ELISA assays and the antibody assays and some of the T-cell assays that we all do. But we were talking about a whole other range of the systems biological assays that are not easy to do and that are expensive to do. And so we have to be willing to invest early in the capacity building if this is really going to happen.
Soumya, you wanted?
No, I wanted to make a point in response to the marketplace for data, and an alternative model could be that when data is used, I mean, data collected from people is used by private companies, for example, then there should be, I think, a commitment to provide also the benefits through the product that's been developed, through access to that data. Just like, we're now saying if a vaccine that's been developed has been funded a lot through the taxpayer funding, through public funding or philanthropic funding, then the company must have a legally binding responsibility to provide that product to the public at an affordable cost. So you have to build in these equity principles into the contract. So similarly, I think, the big companies that are gathering, and it's true that people would be willing to share data if it's going to help someone else. There may be someone with advanced cancer who has really no hope, but they might, get a lot of satisfaction thinking they've helped other patients. But then if those treatments are never going to be accessible to others, then that's not an incentive to share data.
Thank you. Do we have the possibility of taking questions from the audience? Perhaps that now might be the time. Does anybody have questions? Yes, please, and then you.
Thanks very much indeed. A range of different opinions from the panel, which is nice to see, even if I don't agree with all of them. First thing, I would be cautious about being overly simplistic about big global projects and keep going back to the human genome. There are many other big, apparently global projects which have been a disaster and have eaten up so much time and energy by just running the thing that they haven't delivered on the goals of the thing. The human genome was special, but it's not necessarily the model for everything else. The second is, everybody always says to me, this is a role for WHO. WHO can't do everything. And we can't keep putting stuff on WHO and say that's your responsibility, but then not give them any of the ability to do that, the money or the people. So it's just, I think we should be really cautious about saying, WHO, this is your responsibility. I can't imagine WHO being given the responsibility of running the Human Genome Project many years ago, to make the analogy that some of you have made. On the market systems, public health matters as well as individual health. And I'm not sure that I would agree that the market system has necessarily built a more equitable world. And your model of $10,000 for something would suck all of all of that into a very small number of countries. I can't see how that would distribute the benefits of that in terms of wealth generation and indeed health at a more globally, more equitable way. And I'm not sure the analogy with oil really works for individual health as well as community health. And then on the immuno, we've also got to understand that if you're sick today, that comes to something that was imprinted on your immune system, probably in gestation, but certainly in the first few days of life. So unless you're willing to set up cohorts that will follow people for a very long time, the imprinting in the immune system is going to add to a complexity that I'm not sure that we've really considered yet. Over.
So who would like to react to one?
I think the imprinting is really key. And I think it has to be looked at. And frankly, there have to be the cohorts if this was going to be a success. I agree with you completely, Jeremy.
On the role of WHO, I agree that WHO can't coordinate these massive global projects. I think WHO's role is to set some standards and provide guidelines around the ethics, around regulation, and then countries and others have to implement.
Jacques?
Yeah, maybe one comment about the global massive project versus investigator-driven science, which is usually the model. Any big project, and the Immunome is no exception, should definitely not replace individual initiatives, but it can be there to basically decrease the psychological hurdles we have sometimes thinking about big objectives. So because as a community we can declare where we want to go, and that's the role of the Immunome project, it will make it easier for individual researchers to get the funding, to pretend we are going in that direction, and to coordinate between efforts. So I don't see the big Queen Mary replacing efforts that are ongoing, but on the contrary, it's synergistic with what is happening. And that's very important, and I thank this audience member for the remark. It shouldn't be seen as competing against people doing the excellent science they do in immunology today.
There was a hand on the third row here. First, yeah, this lady had her hand up first, and then there are hands in the back.
Thank you. Hi, so I want to start by saying that there's a lot that I don't know, a lot that I don't understand, and a lot that I need to, that I want to learn. But that being said, what I'm taught in school in my own investigations and research and my projects is that when you're using participants and when you're using people, you never actually write their name in the research. You write participant 1, participant 2. So I was wondering if that's the case in real life application of it, isn't there isn't their privacy already there? Isn't there confidentiality already ensured? Or wouldn't it be more important to, you all were talking a lot about the data sharing and how some people steal data and how people are very, they want to keep their data for themselves because they're scared that other people are going to take it or manipulate it or give them consequences. So is it more important to protect the confidentiality, which I thought was already protected, or protect the actual researcher's data and protect his, I guess, sort of copyright on his data?
Who would like to pitch in on this?
Well, it's a good question, and issue is how do you ensure there's adequate de-identification of data? And as you rightly say, name, addresses, and so on are removed. But it's quite possible, if you have enough data points, to bring together the data and re-identify an individual, particularly if you have unique genetic data or genetic or immune types of profiles that could identify. There are some special situations, say in rare diseases, etc., where the numbers are quite small and re-identification may be possible. So and then also images. I mean, can you identify someone through a retinal image? So there are these issues, I think, that we have to look at, and to ascertain what is the adequate degree of de-identification. How do you strip away things that, even if you took all the data with data that's available on the internet, etc., would reduce the risk of re-identification to some acceptable level, in order for us to then be able to protect that individual's confidentiality.
Thank you.
So one brief comment and 3 brief questions on market. So first of all, market does require regulation. It's not either market or regulation. To create a market, you need regulation because you need to define what could be traded in that market, what would be the scope of ownership, etc. So it's not a way of opting out of regulation. Speaking of which, we now have regulation that allow people, the GDPR, for instance, allow people to consent. And so what do you see and that's the first question, what is the difference between the informed consent of people to contribute to a particular study or to contribute to a particular project or to donate their data as opposed to a marketplace? Second, and these are the 2 additional questions, how do you protect against exploitation? We're speaking about, you sort of assume that it's more valuable to have the data of people who are severely ill, and the question is whether that would be ethical to actually find them at that spot and asking them to trade their data and commodify it. And the third question relates to representation. To what extent this marketplace is going to provide us with what we really need, seems to be, for this system, is broad representation. That is where regulation can actually make available all of the data rather than only the data that people are willing to sort of trade voluntarily.
Thank you. This is an extremely important comment. It's not always clear to everyone that exploitation can be consented to and still be exploitation, right? So, yes, Jürgen, I expected you would want to pitch in. Go ahead.
Yeah. It is absolutely correct that our current market economy would not function without regulation. Each country has regulations about their banking systems and about what happens to the zeros and ones in your bank account when you do a transaction from this account to another one. Then there is a regulation which basically makes sure that your own account is going to get a little bit smaller and the other one is going to increase a little bit in value. And all of that is routine and has been working for a long time. And it's different from the vague proposals of the European Union because it's really about arranging the transactions and about the market-based buy and sell operations that you have, or maybe streaming operations when you sell your data repeatedly to different companies, just like a guy who is selling his music and his lyrics on streaming services to many different people who are all using it. Oh, I'll pay a little bit, and the composer of the song gets a few shares of the profits and so on. So there are regulations in place which we just have to adopt to data of this particular type. regulations are central. Without regulations, there's nothing is going to work. We have a constitutional market economy in Switzerland and in many other places, and there is no problem whatsoever, in principle, to transfer these regulations to a working database economy. It's just another type of good which has to be placed on the market through the regulators in a way that allows every little guy, even the poor guys in the poor countries, to become a micro-entrepreneur in his own data.
So we have 2 minutes left, but we started somewhat late, so I'm going to take 2 more hands, the gentleman in the back, and then here the gentleman in the front.
Yes, thanks for such an engaging session. My name is Sandeep Misra, and I work for innovation and digital transformation for industries. So I have one small comment and then a question. So comments is about data is the new oil. So it is also not taken only in the context of money, but it is like oil is required to run all the machines and engine. Exactly like that, all what we talk about, AI, machine learning, will need data. And those who will invest early, like a university or a country or an organization, will reap the benefit in future, because later, if you see all the startups, they don't have the data. And today they are looking for partners who can provide. So this is one comment in that context. And my question is, we are innovating, or we are progressing in science at incredible rate. So my question is, why it is not making it cheaper for the people? Because it is becoming very, very expensive. And when opportunity come, all the organization, government, everyone become opportunistic, and they want to encash on that. So what should we do to make it for a global good? Thank you.
Who would like to pitch in on this one?
So I think on the cost side, it's a good point. And I think that the drivers of cost are because, firstly, some diseases that could not be treated before now can become treatable. And so you're really extending the range of things that you are treating, and therefore it ends up costing more. Second is that even for diseases that have a current set of treatment, augmentations to the treatment improves, right? More predictive, ability to intervene better, etc. So for existing patients with existing problems, you are doing more, and that costs more. And the third is that quite often the innovations don't actually displace existing treatments. So if you have something like a vaccine against cervical cancer, yes, it completely changes the way we treat it, and therefore you do reap many, many cost savings. But most other innovations aren't in that nature. They actually add on, they layer on additional measures, additional tests, additional treatment steps on top of existing ones, and therefore they also add to costs. So there are, this is not to say we shouldn't be doing it. We reap many benefits, patients get better outcomes, but driving down costs requires a separate set of approaches and interventions in order to try to contain the rise of medical inflation.
So, the history tells us that the big science works quite well for physics, and there's a long history of it. In fact, in life science, the only one that really has worked is the genome, probably because there was a very clear endpoint. We've seen and we've tried in the brain area to have a lot of different of those big science projects, but they're struggling because there are no clear endpoints, obviously. So my question is really, how will you avoid this in the Immunome project? And the second thing is the geographical competition. In the brain, for example, there were 4 or 5 of such initiatives. There was huge competition between China had its own, Europe had its own, US had its own. How will you foresee and avoid those pitfalls in the Immunome project?
Well, I think one of the ways is to really articulate a pilot project and show impact on that pilot project. And from our point of view, there are the 2 aspects of that. One is the selection of the immunologic or the disease you're going to work on in that pilot, and the other is the data amalgamation. If we can't get the data amalgamation, right on a pilot project, we're never going to get it right on the international project. And then on the other point you raised, I think I think you're right. I think there have been a range of these enormous initiatives that have failed. I think we have a huge, huge opportunity here, and we have, a series of learnings of those other initiatives also. So I don't think we have to fall into some of the pitfalls that they fell into. But I think it's going to take a pilot, and I think it's going to take a range of partnerships, academic and industry, NGOs and governments. And I think we're going to have to walk the walk and see where we are and show impact after the initial 3 or 5 years.
And this was a wonderful closing statement. Thank you very much, and thank you all.
Imagine the unimaginable.
Yeah, exactly.